You've seen in the memory visualizer that variables have addresses and values. In this video, we'll see how we can take the address of one variable and use it as the value for another. This second address-holding variable is called a pointer. This idea that we can manipulate memory addresses as values is a powerful concept, but it isn't any more difficult than the concepts you've already seen. Let's get started. In this program, we declare an integer I stored on the stack and assign it the value 5. Next, we print the value using printf. We can also print the address where that value is stored using a new operator, ampersand. When applied to a variable name, the ampersand operator returns the address of the variable. Let's look at this program in the memory visualizer. I've already stepped through the program to the point where line 6 has been executed, and we are almost ready to return. If I hover over I in the name table, you can see its address and value in the stack segment of the memory map. Notice that the printf statements printed exactly these numbers, so we see them in the output box. Now let's add a new data type called a pointer. If a variable is a pointer, its value is a memory address. When we declare the pointer, we have to specify the type of the value that will be stored at that memory address. Here we declare a pointer to an integer called pt. We are saying that pt is a variable that will hold the address of an integer. We refer to the type of pt as int star, or pointer to int. Using the ampersand operator again, we assign the address of I to pt. Remember that when using an assignment statement, the new value of the variable on the left-hand side is the result of evaluating the expression on the right-hand side. Now we say that pt points to I, or I is pointed at by pt. Let's look again at the visualizer and start at the point where we are about to declare pt. When pt is declared, it appears on the stack name table, and its type is int star. It is stored starting at this address. On my machine running the visualizer, addresses are 8 bytes, or if you prefer, 64 bits. So a variable of type int star needs 8 bytes. The visualizer shows the address for both of the 4-byte pieces allocated for pt. Here is the initial value of pt. We haven't set it yet, so it just holds whatever junk was previously stored at this address. Let's execute the next line of our program. We assign the address of I to pt. So pt holds this address, and this address holds 5. It is important to understand that when we allocated space for pt, we only allocated space for a pointer, and not also for an integer. The integer was allocated when I was created. We only use pt to hold the address of that memory. Now, we would like to access the value in the memory pointed at by pt. Let's add one more line of code to our program. The star operator is applied to a pointer and evaluates to the value of the memory pointed at by the pointer. This is called dereferencing a pointer. In our new line, we use star pt to print the values stored at the memory pointed to by pt. Let's run that last line in the visualizer. So pt holds a memory address, and that memory address holds the value 5. So star pt evaluates to 5. Notice that we used the star symbol in front of pt earlier in our program. In this line, we were declaring pt to have type int star. That use of star inside a declaration is not a dereference. It's part of the type. But here, inside an expression, the star symbol is the dereference operator. It tells the compiler to use the value stored in the address that is stored in pt. So far, we've only seen pointers to integers, but we can have pointer to other types. Let's visualize this program, which declares a char variable ch to hold the value uppercase Y, declares a pointer to char chpt, points it at ch, and finally prints out the dereferenced value. Before continuing to the next video, I suggest that you download the 2 example programs and step through them yourself in the visualizer. Pay attention to the values that are being printed and the values and addresses of the variables in the memory map.